Okay, this is lesson number 9.1. So last time I explained to you the introduction of the vectors. So today I will just go briefly about addition, subtraction of vectors. So first thing, what did we learn last time was, I can draw a vector. What is vector is directed line segment, and I can, let's say there's a point from the origin, and I go all the way to this. This point is 4 and 3. So this 4, 3 ordered pair just represents only the point. But if I want to draw a directed line segment, that means line segment with direction from here. So this is a vector. This whole thing is a vector beginning from origin until here. So the question is, how do we represent this? I will call this as V bar. So this is V bar, the vector beginning from here to this point. Now I can call this point, let's call it an uppercase. So V, this V stands for uppercase, is the representation of the point. This lowercase v with the little arrow, that's the vector, the whole red color. The point black is this, but then how do we represent the vector? We want to see the horizontal component. So from here you drop all the way to 4, and you can see this is 4, and this is called horizontal component, and which we will also later on we will call them also scalar projection on the x-axis. So this graph, this distance is 4. So the main thing is, okay, this is the point, but then how do we represent this? Is we write this as 4, 3. So you can see this means vector from 0 from O. So this point is O, and this point is this point. Let's call this as point V, and the point here is this is 4 and 3. So the two different ways to represent black point is the red is the vector 4 and 3. So hope that makes sense. Now there's another thing we need to know is what is the meaning of unit vector. So let's write down what is a unit. So we know what is this one. V is vector, definition, line segment, and representation. So what is a unit? So one more thing I forgot is in this example, what is the magnitude of this? So the magnitude before this is the magnitude of the vector V bar, V and little arrow to show that's a vector is denoted by, so you write it like a V and put a absolute value. That means this basically means how much is the distance. So all you do is, let's see, if I want to know what is this distance, we can think of Pythagorean formula. This is 4. So the horizontal component is 4 and the vertical component is 3. All you do is square this 4 and 3 square and put a square root sign. So that is the hypotenuse, the distance, the red color. So this distance is 4 square plus 3 square. That's all you do. So in other words, you know the answer. It is 5 because 16 plus 9 is 25 and square root of 25 is 5. So you're done. So that's the magnitude of the vector. And then we can also figure out what is the angle made by this angle. So there's one more thing also I want to say. This angle, so how much is this angle measures with the x-axis? So in what is the inclination of the vector? How do we do this? You have this 3 and that is 4 opposite. So tan theta is opposite over adjacent, that is 3 by 4, and you just do theta equals tan inverse of 3 by 4 and you're done. See? So now we can generalize that. If you have one more thing I forgot, anything starts from 0, this vector is called there is a name given to you if anything starts in this position vector. So this is called position vector. Now what is the meaning of position vector? Means shortcut is PV vector from 0 to V. So it means 0 to V, this 0 to V vector is written as position vector V bar. That means starts from here. So take a note of this. So position vector is lowercase and that's it. Now another question we need to also understand. You understood horizontal component. That's the vertical component. Oh, the angle part. So that's the angle. And now comes what is a unit vector. Oh, let's generalize. What is the meaning of generalize? This basically means if this is like V, like if whatever the vector V, if the vector V is some A1 and A2, so we are going to write like A1, A2 means the horizontal component and the vertical component. So we write A1, A2. So if this is the vector, then the magnitude of this vector is, put a square. That's like a formula you remember, A1 square plus A2 square. This is one thing. And then the second part is what is the angle with the horizontal component, or the vector mix with the horizontal component is tan inverse of B. So this is like a A1, A2, right? So it is the y coordinate divided by A1. So that's it. So you learn. So what did we get this from here is magnitude formula and also the angle formula. And hope this helps to understand. So what I'm gonna do next is how do we add and subtract. So let's take. Oh, okay, let me, I always forget. So if this was a vector V, one more thing, what is the unit vector? So, sorry about that. So this was 5, right? This was the vector, correct? So I think I forgot about what is the unit vector, right? So unit vector defined as vector who has so unit vector is nothing but it is a vector, but having magnitude. So we could put it like a small symbol. That means it's a unit vector. So this unit vector is magnitude is 1. In other words, if this is 5, remember the one that we got did is this was 3 and this was 4, and we have seen the length of the hypotenuse was 5. So where is the unit vector here? This is V bar. So if that is V bar, we have to break this into 5 parts. 1, 2, 3, and 4 and 5. So the unit vector is going to be. So the unit vector will be. So this is going to be the unit. See this part? This is the unit vector. So this unit vector is written as, because you need to have this is only the magnitude. So you want to know the direction, then we are going to write it a vector V bar, whatever the vector is. So V bar divide by V bar cap. So this is also called, so it is V, or you can just put like this and say put like this. So that's the magnitude. Any vector, if you want to know what is the unit vector, all you do is divide by this. Now in this example, this was the vector, V was the vector. What was the vector V was? It was 4 and 3. So 4 and 3, that's the vector. So this is 4 and 3. So the V cap, it means the unit vector along this V bar is the same green. Okay, so the same vector, but you divide by this. Now remember, this vector is this 4 and 3, and that means now you have the magnitude of this was 5, so this is divided by 5. So basically it is divided by 5 like this. So your new vector is this one. So because this point, if that is 4, 3, the point will be 4 by 5 and 3 by 5. But to write the vector, this is how I should write. That's the difference between the ordered pair, the point, black point is there, but the vector is there. And you can see here, it is 4 by 5 and 3 by 5, and it is done. So all you do is, so I want you to get used to this to understand this, the symbolic notation, because very soon we are going to do later class that what is the meaning of projections. There is something called projection. So projection vector of, let's say, this V, so there will be V, projection of this V on another vector, let's say U bar. So there will be kind of a formula where you are supposed to write what is the projection of V, vector V bar on U bar, something like that. And we are going to use something called dot product, where you're going to use U dot V bar like this, then divide by V bar, the square, this whole thing, and then you are going to multiply by the unit vector of the V bar, which is going to be V bar. So this V bar and vector V divided by one of them gives you. So that's what we are going to. Main goal is, in order to understand this, you really want to get this fundamentals right. That okay, you know what is a vector, you know how to represent, you know what is a unit vector, you know what is the angle to find out, and that's all it is. Okay, once we do this, then which are the unit vector you can think? There are special unit vectors here. Is two spatial vectors that we can think is, one is along the x-axis. So this is important. Along the x-axis is here, that is 1, right? You know this is 1 because it is 1. This distance is 1. But, because of that, we write this is I cap. So that's what. Anything on the y-axis is written as j cap. So remember, unit vector along this. It could be I cap here also. So this also is I cap, the unit vector. It could be this one. This also is. It could be this one. This is j cap. So j vector. Now why I need this is unit vector is, now there is another representation is how do we add two vectors? So let me do one more time. 1, 2, 3, 4, 5, 6, 7. So if there is a vector 1, so let me take this vector is so one vector is this, and I can call this as U bar, and you can clearly see that this 3 and 2, right? So that's, and there's another vector V, and this one will take it 1, 4. Okay, so this vector. So we want to understand what is the meaning. Now this is 1 and 4, and I did it on purpose. 1 and 4. So how do we add? So the question is, what is the meaning of U bar plus V bar? So what happens, what it that means is, the definition says, if I want to find the new vector, so this vector is U bar and this one is vector V bar. So what is U bar plus V bar? Basically, definition is if you see this part, the horizontal component for this vector is 1, the horizontal component of this vector is 3. All you do is, we can write this vector, translate this vector, and keep the beginning point of this O, let's call this as U, and this point call it as V, and I can pull this up like this. So I can go like this. Okay. And then the other one will be, so you can complete a parallelogram. So the definition of how do we add this is nothing but you are joining this to this is the new vector. Because, so basically what it means is, if you have one vector here, 0 from here to here, and then this vector goes from here to this point, then your final destination is that point, right? So from here to here, and this is defined as u plus v bar. Now I call it w here, this is also called w bar, where this point basically is just adding the 3 of this, so this is the 3 and you're adding to 1 and it goes to 4. So this is 4 and you're adding this to 4 and that point is like almost like 6 here. So this is 4 and 6. Hope that makes sense. Okay, again I repeat, if you have a vector u bar and there is another vector, let's say this one, we can move this vector v bar and in such a way that this point goes to the tip of this u bar and then it ends somewhere there, and that point we can call w, the last final one, and the vector here is, I always forget to put the arrow. So this is the diagonal is, so if you complete this, the new vector is nothing but it is the so this vector is the diagonal of the parallelogram formed by these two vectors u bar and v bar. So that's it. So simple. But then the question is, so what is u bar? So this is the new vector w. This is how you add two vectors. Then what about, so this means u bar and this v bar is right here. So u bar plus v bar is w bar. So start from this point, this is u, then you go from this is, you end up getting here, that's the new vector. So that's u plus v bar. So the diagonal, you can complete a parallelogram out of it. But what is the meaning of next is another thing which is, I'll put a y bar, let me say, what is u bar minus v bar? Remember, if you have a vector like this, if this is the vector, is called this as p vector, then the other side opposite, in the opposite direction, it is minus p bar. So then now I'm going to take this off. Okay. So we want to know what is, okay, this is u bar and v bar, and this point was 1 and 4, right? And this point is u and this point is v, right? Now what is u bar minus v bar? So that's what we want to know, or so I want to know, watch this. This basically means you are adding u bar vector plus negative of v bar. That means we need to know where is the negative of v bar. So I have to complete again the same. I think I should not have, so this is that thing. So this was the w, right, which was 3, 4 and 6. So now if this is u bar, this also is u bar, this is u bar. Okay, now this is v bar, this is v bar. But if you go this side, it is negative v bar. See, so that means if I start from this point and you go to here and then go here, then your final destination will be so the final destination will be this one. Okay, so that is. So this is u bar, so that is u bar plus of minus v, that is minus v bar. So this is geometrically what it means is from v to u. So what we will learn here is a vector v bar, that is nothing but vector v u bar. See this? So you from this to this vector, let me draw, so this part, this vector is u bar minus v bar. How do we get? You start from here to here, which is u bar, then you go this side minus v bar because this is v bar, and that is the geometrical understanding. It's the other diagonal. This is the other diagonal. So the first one that we've seen was this part. When you complete it like this, this was the first one, u plus v, that is u and v. So this is u plus v, but this one is u minus v, which is from v to u. It's just becomes the opposite. So if I have this v and u, So this part, u starts first, see? So it is u minus v. So in other words, if there was anything, we can in general always remember, if I have m n, you want to write n vector, you just do the second one, so you write that position vector minus the m vector. That's all you do. I hope that helps. And then the rest is the, if I want to know what is this vector, all you do is, let's say vu. So vu, the vector is, the formula is, call it, so it is v u minus v. So u minus v, that's all you do, see. So it is u is 3, 2, let's write 3, 2, and v is 1 and 4. You just subtract it, you get the answer. 3 minus 1 is 2, and 2 minus 2. So that vector, this vector basically is 2, 2. And you can clearly see the reason is, if I want to write its position vector, this vu, 2, where is 2? This is 2, and then I have to go down. This is minus 1 and minus 2. So this point is minus 2 and plus 2, but the vector is minus 2. So this vector, whatever you see here, this solid vector, this u minus, it is right here, so it is also here. That's the vector, u minus v. So this is the position vector, and this is, it could be anywhere. I can draw another vector, same thing like this, or this way, or I can have another one this way, or another one this way. So it can be anywhere, direction is the same, and you can see it goes 2 down, it's like it's going 2 down and 2 right, see. So it goes 2 down and 2 right, and you can see it is going 2 down and 2 right. So it has a horizontal component is 2, and the vertical component also is 2. So, and you can see this is the same thing. Horizontally is 2, and the vertical also is 2. So with this, I want to complete with what is addition and subtraction, or what I wanted to show is in general, how do we add and subtract vector is if you have vector p, let's see, this is a1, a2, and the other vector is b1, b2. All you do is, if this is u bar and this is v bar, so u plus v bar is just a1 plus b1 and a2 plus b2. And if it is a subtraction, then it is a1 minus b1 and a2 minus b2. That's it. Hope this helps video just to understand about the first part of this. Now I'm going to go to another part is this side. So understanding the meaning of dot product. So let's see what is dot product. So I have taken a point. We want to understand what is the meaning of dot product. So the definition is, so the definition of if there are two vectors u bar and v bar, there is a vector this one is always this one. So what is that means is, if you have a vector, so this one vector is, I'm going to take 12 and 5. So this is the one vector. So this is vector 12, 5. So this is 12, 5. First vector, that is u bar. That's vector 12, 5. And then let's take another one is 8. And the question is, so 6 and so this is vector. This vector is 6 and that is 8, right? Now question is, what is the meaning of this dot product? Watch this. So if this is u and what is this theta basically means? The angle between the two vectors. So this is theta. Okay. Now what I'm going to do is drop a perpendicular. Drop a perpendicular. What does that? This is by definition, right? So that's the definition. So this is just the definition. Is u bar dot v bar is magnitude of this one and magnitude of that one. I also want you to know that we all know that if you drop this 12, so 5, 12, and 13 is a Pythagorean triplet because they form a right triangle. And also 6, 8, 10 also forms a, and that's why I selected this two, so that the magnitude wise, this u bar is, if this is 12, I can drop a triangle and like this, and it's become a right triangle, and this magnitude here is, this magnitude is 13, and just write down that's 13. If you take the 12 square plus 5 square, take a square root, you get 30. And this 6 square plus square, if you do 36 plus 64, and add them 100, you get, this is time, this is V bar. So what is the definition I want you to understand? What is the meaning of? What does this basically means? Is if I try to drop a perpendicular here, let me take this off now. This is the so what is it? From here and drop one. Okay, this is 90 degrees. Call this as, this is O, this point is, let's call this as U, this point is V, and this point, let's call it as M. So we have something called, what is this basically means, is if this is the theta, this becomes like the opposite side, this is the adjacent side. So by definition of cosine theta is adjacent to a hypotenuse, so which is this one, VM, this part, okay, sorry, OM, right, OM, so which is OM, and I'm going to write this, is if it is OM, we want to know what is this OM, right, so let's write it, OM, and divide by the magnitude of this, see, the hypotenuse. So the hypotenuse, I'm going to take, even though you know it is a 10, but I want to use, it is 10, but I'm going to use magnitude O is with the absolute, with those signs, right? So the OM, so this is distance O to M, and then the other one is OV, let's write it, OV. Now these are the distances I'm using, adjacent of a hypotenuse, so which is that means OV we know, so the OV is this part, so this part is OM over V and this one, so then I multiply, but this is magnitude, right? So when I multiply OM both sides, so OM, this is called, it is the scalar projection. So I just want you to understand that it is a scalar projection of V bar, so it's a projection of V bar over U bar. So OM is multiplying both sides. So multiplying both sides by OM this side, and also multiply OM here, like this is magnitude, right? So all you get is that OM equals this OM is OM. Sorry, you're not multiplying OM. You're multiplying. See, I have another class. Very soon I have to. So this is what I'm talking about. So it is the V bar times cosine theta. So this is the projection. So this means this part is V bar, this part is cosine theta. And what is, for this part, u bar, the definition says it is u bar, I can write u bar dot v bar is u bar v bar, the magnitude, this basically means just multiplying the magnitude and time cosine theta. I'll try to combine this together. So v bar, so u bar, and then I'll put a cosine theta times, and then this one. Now if you see this, what's happening is this part is the projection, this part, this is. So basically the dot product is just a product of, so the dot product is nothing but this times this whole thing. Now which whole thing I'm talking about is this part. See, this is u bar. So you're multiplying the scalar projection of vector v bar along the u bar. So this is, again I repeat, this part is the projection, scalar projection of this v bar on it, along the u bar. So that's this part. So you're multiplying this times that. Okay, so that's all that means. But then you will see, if I give this points, like this is the u1, and this is a1, and this is a2, and this is b1 and b2, then we will see that. I'll make another video that this vector a dot v bar is nothing but a1 times b1 plus a times to b2. So this is the answer for this. So this is the theorem. We have to prove why it is like this. The definition is this, but why it is like that. So in other words, this answer that we have here right now is, remember this answer is u bar. So what is the magnitude of u bar? It is a Pythagorean triplet of 5, 12 and 13. So this is 12, so this is u bar is 12, so that's 12. V bar was, if you see this V bar, if this distance is, I make a slight mistake, yeah, 6, 8. Yeah, this was 10, correct? So this was 10, we have already seen that. If I try to drop a perpendicular, like you see, 90, so this is like, so this is 6, this is 6. That is 8, so 6, 8 and 10, they go together. So this is 10, so V bar is 10, so this is 10. And whatever the cosine of the angle, that's it. Too much stuff is going on. Okay, let me conclude now. What did I say is, dot product is, they said, okay, let's define it by, if you want to multiply two vectors with the dot product, so don't multiply dot product. You have to multiply the two magnitudes of the orange magnitude and this one, the blue one, and then you multiply cosine of. That's all it is. But then we saw also that this thing is that this part is v bar cosine. That's a projection, scalar projection of the blue one on it. And then basically you're multiplying the meaning of the geometrical meaning of this is nothing but you're just multiplying the scalar projection of this vector along this part, this piece multiplied to that piece. That's all. You're multiplying this piece to that piece. Okay. Now, in the next part, we want to know is what is the projection vector? Now comes what is the name? Projection vector of this v bar along u bar.